Greetings! Welcome to Chapter 4, Discrete Random Variables, Lesson 4.1, Probability Distribution Function for Discrete Random Variable. Get to know the new terminology for this lesson. Click on each of the words, learn its definition and meaning. When you are ready, click Continue. Over the next several lessons, we're going to be talking about very specific probability distribution functions. Let's first talk about the generic one. For short, we'll call it PDF. The PDF has two characteristics. Each probability is between 0 and 1 inclusive. So the sum of probabilities is 1. A child psychologist is interested in the number of times a newborn baby's crying wakes up its mother after midnight. For a random sample of 50 mothers, the following information was obtained. We're going to let capital X be the number of times per week the baby's crying wakes up the mom after midnight. For this example, little x can be 0, 1, 2, 3, 4, or 5, meaning the number of times they woke him up. So either 0 times, 1 time, 2 times, 3 times, 4 times, 5 times. The probability is this. We have a total of 50 moms. There were 2 moms out of the 50 whose baby did not wake up after midnight. So they woke up 0 times. The probability of 0 times waking up is 2/50. 11 moms experience their baby waking up 1 time per week after midnight, and therefore the probability of x equals 1, or probability of 1, equals 11/50. 23 moms experience their baby waking up 2 times per week after midnight, and therefore the probability of 2 is 23/50. 9 moms experience their baby waking up 3 times after midnight per week, and therefore the probability of 3 is 9/50. 4 moms experience their baby waking up 4 times per week after midnight, and therefore the probability of x equal 4, or probability of 4, is 4/50. The number of moms that experience their baby waking up 5 times per week after midnight is 1, and therefore the probability of 5 is 1/50. Now I went ahead and I left these fractions as in terms of 50ths because it makes it easier for our next step. Generally, you will either turn these fractions into decimals or you will show your answer in reduced form. This is a discrete PDF because our probabilities, when we add them up, 2/50 plus 11/50 plus 23/50 plus 9/50 plus 4/50 plus 1/50 is 50/50, and that equals 1. That's what a probability distribution function looks like. Here we have a problem, and we're going to walk through gathering all the information and answering the questions and filling out a table. Suppose Nancy has classes 3 days per week. She attends classes 3 days a week, 80% of the time, 2 days a week, 50% of the time, 1 day a week, 4% of the time, and no days a week, 1% of the time. Suppose 1 week is randomly selected. What is the random variable capital X? Now, capital X is always going to be dealing with what are we testing, and therefore it's the number of days Nancy attends per class each week. What values does the random variable X take on? Well, she can either go to class 3 days a week, 2 days a week, 1 day a week, or no days a week, so that's 0, 1, 2, 3. What does the probability distribution table look like? So what are our X values again? 0, 1, 2, 3. And what's the corresponding probability with those X values? So if she attends 0 days a week, that was 1%, or 0.01. So P of X, P of 0, is 0.01. When she attended 1 day a week, that was 4% of the time. In other words, the probability of 1 is 0.04. She attended 2 days a week. That's 15% of the time, so that's 0.15. When X was 3, where she attended 3 days a week, that is 0.80. And just to be sure, let's add up those probabilities and verify they do equal 1. So 0.1 plus 0.4 plus 0.15 plus 0.80. 1 plus 4 is 5 plus 15 is 20. 20 plus 80 is 100, so 1.00. You've reached the end of this lesson.